Welcome back. Because this is in the foreground, we can do another chain here. So I'm going to just organize things. We have a lot of points here. So let me organize this again. Let me. Okay, surface white water. I want to start the selection by taking the points. So I'm going to press 1C here and object merge, paste to have our points, the same thing that we have. First, we can just select just the spray particles. So that's already going to alleviate a lot for us. So I'm going to just delete at spray is bigger than 0.1, and I want to delete non-selected. Right, so let me see. All right, okay, I need to set these 2 points, and now I have it. So these are the spray that we have in our simulation. Then I want to grab the spray that is flying fast in this direction, right? Like so, positive X. So we can do like a group expression. And in the group expression, it's a very powerful tool that I've been using more and more. Before I do all the selections and the deletions and everything in VOPs, but now I'm using this more often, and I'm quite liking it. So this, let's say the group name, let's call this spray emit, right? And it's a points. And here you see there is already a lot of templates for us based on what we want. So if you think like the x coordinate less than, we can use that, but it's not what we want. We want the vector v at v dot y is bigger, is smaller than 0.5. Okay, so I'm just making a selection for wherever the vector of this, the velocities of in the y-axis is smaller than 0.5. So that's the selection that I'm making, that if the vector is bigger than is going up, right, it's not being selected. It's just selecting everything that is going down on here. And then I want to blast that. And just come here and say spray emit. And we get left with this. We're just getting the particles that are kind of flying with a little bit of upper vector. Okay, we deleted everything that was going down, right? Because the waves, the turbulence of the waves, it emits particles going up. But imagine that when the particle is going up, it has a lot of power and velocity, but then the gravity is going to make them fall down and they're going to start dying. And you don't want to emit from the dying particles, the particles that are falling down. So what I'm doing here, I'm creating a threshold based on the particles that are still very alive. Because for a particle to go up against gravity is because it's very alive. There's a lot of strength in it, and it means that it can emit mist and spray from it. That's the logic behind it. So I also want to make like a box, because you see we have like these edges. We have a lot of particles in these edges, and we don't want that. So we can just delete those. I'm going to just make like a delete. You can like make like maybe the same technique that we did so many times. We can do a a time shift. Time shift, kill this, bound, like that. We need to now reduce that, like maybe -1, -1, -1, -1. And we can maybe increase that like 2 and 2. So we're not deleting on the top, but on the sides. And we can just create a group if I can find it. All right, it's points, bounding object. So you see we're just deleting that. I can maybe reduce a little bit more. Maybe we want 0.5, -1.5. Okay, I think I want to go even further there, so maybe -3 here. Yeah, we don't want that part to be emitting particles. Everything else is good. And now we blast. Let's call this group D as delete. Now select. And we delete no selected, group D, and that's great. When you're deleting a group and the group has like it's already group defined on point, if you come to the blast, you delete, you don't need to specify, it gets from the group. But when you use an expression here, as we did as the spray, you need to specify it, otherwise it's not going to select, you know. That's just one thing to understand. Okay, now we don't need a lot of attributes for that. We just want to keep like maybe we can do like an attribute delete, and let's keep only the Pscale and the velocity and nothing else. We can say delete non selected. We are very clean now, and I think it's better if we cache that, so I'm going to do a file cache in here. And then for the simulation itself, we're going to do something very simple. We're going to do a pop simulation. So it's very fast to calculate. So we do like a pop network. The pop network is a DOP network, a dynamic operation, but it's already preset for us the chain of nodes to do a pop network. That is just like a particles simulation. It doesn't, the particle simulation, the difference from that and the whitewater and the flip sim is that those simulations, the flip and the whitewater, each particle, they need to analyze the particles around them, and they get large influenced by every neighbor, in the sense that like they're not flying simulating individually, but rather in a group and in a full system. The pop network by default, if you're not placing different type of forces on it, like with the fluid pop fluid or whatever, it just individually, each particle get like the forces that are being applied to them, and they just do whatever they should do regardless of the neighbors. So that's why it's so fast to simulate. So we're going to just pop this in the first input here, and let's call this guy a spray sim, right? Like wave spray sim. Cool. Let's dive inside. It's already unchecked, disabled the simulation, so we can go in here without worry that is going to keep simulating. And let's bring this guy on top. Here, first input. We want not to scatter on surface. We already have the points, so we want all points. And the geometry is the first context geometry. So it's over because we plugged here. If you do not plug, it's fine. You can just set like as a dop object, and you just define the path here. Okay, so for the birth, we can set a life for it, like 2 seconds maybe, and with some life variance, like 0.25. And the negative and positive means it's a good way, like imagine if all the particles are here and they're emitting at the same time, and then every frame again you can see like some stepping happening. This is a cheap way. Instead of increasing substeps, you can just jitter the time randomly by it's going to jitter based on the birth time. If you say positive, it's going to be jitter from the moment that they should born to the moment ahead of it. I prefer in this case to get like the negative, so it just doesn't have like a particle flying before the wave really reaches it, but it would work and also. And then in the attributes, I want to just give some variance, so I'm going to add to inherit velocity. That means that we are bringing 100% of the velocity of the particles that we defined, but we also want to add some variance to it. Like, so I want to do like 5, 0 up. I don't want to change that, but then also like variations in the X and the Z. And the velocity here is 0. Don't worry, it's not 0, is adding 0 to it. It's not multiplying. This is not a multiplier, so it's adding. So I'm just not adding more velocities to it because we're going to advect by the force of the wind anyway. So it's all good. Let's do pop advect by volumes. We used this before. And here we should define the path of our wind force. So let's check the wind, out wind force. Great. We up the force. We don't need to treat as wind, and we can use the force of 2 in here. Yeah, that's good. A little bit of pop drag, but we're going to do something with that so we can randomize a little bit. So pop drag. Oh, yeah, it works as well if you do like that, like merging. But I'm just going to do in chain. So I'm going to do 0.01, but we're going to use a vex expression. We're going to say that this, if you hover on it, you see the name of the attribute. So this is the air resistance, or you can just come here and do any of this. It's going to give you what you want. So I'm going to delete everything. So what I want to do, I'm going to say that the air resistance is going to multiply itself by a random number. So what I mean is, like, based on the particle ID, we're going to get like 100% of this or less. We're going to fit range. So to do that, you just do like fit 01. So it means that like it's fitting already from 0 to 1. And then we want to say like ran. That means the random IG at IG. And then we're going to define how we want to, because it's coming from 0 to 1. And now we're going to do like 0.6 to 1. Okay? This means that some particles are going to have like 40% less than this, and some particles are going to have 100%, and anything between those, because the float, it's a float value, so we have like 0.0661712, any number between this and this, they're going to be randomized. So some particles are going to get more air resistance than other, and that's the look that we want. If you want to save that, you this preset, for example, you can come in here and come to save preset and say like random IG, for example, and then the user preference, and save the preset. The next time, if you do like a pop drag, for example, you can already come in here and come to random IG, and it's going to have like this saved for you. That's great. All right. Also, the pop, instead of if you see the solver here, it doesn't have the regular bounds that we normally have, like the limits. So we need to do like a pop kill for that. So let's do a pop kill. And for that, what we can do, I think we can use the wind itself to define it that. So let me think about it. Yeah, I think the wind, if we go here, let me go to the wind and to disable that for now. And in the wind, we have like the bound in here, right? Like, so I'm going to say no outbound and place this in manual because it's faster for it to read. And you can say like the bounding we want to enable, and then in the size we're going to search for that. So you go to reference scene data, right? Like, so size reference scene data. If you have like this in not in manual, sometimes it takes some time to load. So we come to the wind, we come to the outbound, and in the bounding object we have like the centroid and the size. So you can select the size and accept. It's going to bring that size. And now the center, we can do the same thing. We can come to reference scene data, object, wind, outbound, bounding box, centroid. So it's having all that for us. Great. If you read like that, it's going to delete everything inside this, but we want to delete everything that's outside. So when it leaves that big box, it's going to get deleted, right? And we can also do like some random deletion. So this is also something to just randomize and some particles get deleted. So we can enable that, add to kill list. We can just say like maybe 04, and let's change the seed here just for fun. So we don't have all the particles. We just need a little bit of them. So it's all good. We don't need to change anything here. It's all good. And then in the solver, I don't think we need to change anything either. So yeah, it's all set up nicely. Maybe we can even like the sub steps. Yeah, it's one. We don't need more. I think it's good. So we have like the emission we have here, and then we need to just do like the regular .io. And this is the node. This is also the node, but we need like a pop object and particles. So we just need the particles. We don't need anything to collide. The bolt, it's not really important. We just want to do a very fast sim. And let's do some attributes delete again, just to save some space. Basically in this, I just want to have like a, let's go to the beginning. Let me see if this is cached to take away from the manual. Yeah, I had this cached already, so it's good. This is what we're going to emit from. That's great. So we're taking the spray particles, we're killing the spray that are going down, and that's all we need. All right, so now if we go here and do just one, let me also, if I go just one frame, oh, we need to go one back and 1/4. But then it's going to give us all the attributes that we want. And I just want to keep the velocity, so delete non-selected. And cook. I already have it. So see you in the next lesson. Thank you. Here it is. We have roughly 1,000,000 points, but it runs really fast compared to the whitewater sim or to the, and it much more forgiving in the system. So it's very easy. And here is the simulation. So you see it's a lot of points and it looks strange, but trust me, it's going to look really good and it connects everything. So the idea behind is like this is going to be thrown away, right? Like I'm going to use from 72 forward. So this is what I want to render. So all this behind is just pre-roll. Let's see. So let me draw something here quickly. Okay. When the particle born, like the spray born, is born from a white water particle or for water particle. So it has like this size, right? Like, and once it travels and it gains speed and it's not connected to the water, what happens is that like this big one get like smaller and smaller and smaller because these start to become like a mist, like the spray, the particle of white water, the particle of water becomes a white water with air inside, and then it becomes this tiny particle of spray, and then it's going to become just smoke that is just like just smoke, like a mist, like barely little particles. So my idea to create the Pscale for that is by age. Once the particle is traveling longer, it's becoming smaller and smaller and smaller. So let's implement that. It's very simple, very straightforward. Let's do a point VOP. Oh, sorry. Point VOP. And let's call this Pscale by age. And let's dive inside. So age is the age that we have. Like, for example, imagine the attribute age, right? How old are you? I am like, I'm 41 years old. Okay, that's my real age at this moment. And what is life? Life is how long the particle will live. We set that in the simulation. So in our case, the particles will live 2 seconds. But imagine if my life is 80 years old. So I'm more or less at halfway. So if I divided the age by the life, we're going to get like a 0.5, right? If I was 1 year old, if I divided that, I would be like, or 0 years old if I just born. If you divide 0 by 80, you get 0. And if I'm 80 years old, I'm almost like in the last year of my life. If you have like 80 years old and you divide 80 by 80, you get 1. So when you divide the age by life, you're going to get like a normalized value from 0 to 1, where 1 is going to be white when the particle is very old and black when they just born. Like, and delete this. And great. So let's do it. Divide age by life. This is giving me the normalized life of the particles. You see, they just born, they're black. Once they start traveling, they become more white. If they're not fully white, it's just because it's the initial of the cycle. So here, when they're just about to die here, for example, they're fully 1, and then they will die. Okay, so this is the normalized age. We need to do like a fit range first and inverse that. So I'm going to do a fit range. I'm going to inverse that. So now when the particle they're born, they are fully 1, and when they're about to die, they get like they get black. You see here? Yeah. So now instead of making the particles be slightly going to make it like more control it. Sorry, to better control this, we can use a ramp. So I'm going to place a ramp, and let's call this ramp age. Let's call this age, and this can be a spline ramp. Again, for us to visualize that, we need to go one level up like this. And if I make this again, you see that we have like a from 0 to 1 again is whatever we have. But what I want to have, I want to actually have like this, the particle born very small, so they just don't appear in the screen very big. They kind of like a little bit tiny, maybe not 100% like a 0, otherwise they will pop, but something more like that. And then I want to convert all that to B-spline, so they have like this more natural. And I want to keep them bigger for a little bit before they start to fade, and more or less like that. So we have like a particle that born get like a little bit bigger, and then with time it's just going to fade away. That's great. And we want to export that to be Pscale, but for that we need to refit that because it now is 0 to 1, so we need to do like a fit range again. And I want to refit that instead of going from 0 to it's coming from 0 to 1, but I want to get like them 0.002, 0.0045, something like that. And then we can bind export. Scale. And also I want to remap that to be able to have like some density on them as well. So I'm going to copy this and let's call this density. But the density, we need different values. Wherever the particle is almost dying, I want to have like this little bit less than 1. But when the particle is very very like is a bigger Pscale when it's very active, I want to have like a density of 3. So we just have like that. Now if we look through the camera view and change that to view through disks, you see how little bit small the particles are. And then they're going to become a mist and volume, like that we're going to do in our next lesson. We're going to come back and start to build our smoke simulation. That is going to be our foreground mist layer for the water spray. Okay, see you. Thank you. Welcome back. Let's create the mists for our spray particles. So first I want to delete them by age. So let's place like a blast. And we can just go ahead and say at age is smaller than 0.05. Delete non selected. And we have anything here? Let me see. Okay, we don't have any Pscale, so that's why. Oh, I need to change that to points. Sorry. Yeah. All right, so this is our the base for emission. I need to create Pscale for them, so I'm going to create a Pscale. So let's do. We don't need this Pscale maybe, or we can use that. For that, we just go in here, and we already have the Pscale now. We can now, I don't know. Sometimes if the particle have like just a little 1 point, something like that, it's not very good for it to emit because it looks really strange, 1 point emitting smoke. So I want to delete that and just keep the more denser areas and kill the particles that are kind of like solo flying around. We can do like in a point pop, and it's a density search. So let's call delete solo. I mean, solo is just for us to understand the like less dense areas. And then what we need to use is a PC open, point cloud open. And we're going to look the input one. Input one is ourselves, so that should be in the file. And then the P is the position. Okay, so what is that? Is creating a PC open. It's a way for the particles to get information based on the particles around themselves. So in this case, it's searching a radius of 0.1, so 10 centimeters, and it's looking for 10 points. And what we need to see is like PC num found. I want to see how many particles they found with the setting the parameters that we define. Okay. And then I want to, you can compare, or you can like, maybe we can just, I don't know, like compare, or we can do like a fit range. Yeah, let's fit range. And then with that, we just need to expose this, so the maximum number of points. I'm going to middle click and say constant. That's going to give us this. And the fit range is like that. We're looking from 0 to the maximum number of points that we set here. And that's giving us 0 to 1. So if I plug this in here, you see like some particles, they don't find anything. But if I increase this to 50, for example, more particles are not going to find anything, right? So then we can just delete, but I don't want to delete. I just want to delete the ones that are fully black, that they didn't find anyone, and not the gray ones. I think we can still emit from those, but I don't want to emit from these ones. So what we can do like a compare. And I want to say wherever is equal to 0, wherever is equal to 0 or is less than 0.01. Why is not working? Not sure. So let's do like a CG point remove points. And a little bit, why is that? Okay, so the fit range, everything that is, okay, now it's deleting that. I think the numbers are a little bit too big. I think I can keep like that as 10, and maybe I can increase that to 15, or maybe no, let's get like 50, and let's decrease that to 0.75. Okay, so now it's deleting more and keeping more around the parts that we have more. This is the HDA. It's just like getting a switch between. I'm going to provide that, but it's just a way to remove the particles. So it's getting like when it's -1, is not returning any result, and otherwise returning the point number that is going to delete based on wherever we define as the threshold or the bias to define that. All right, so delete solo. We deleted a lot of that. And now what we need to do is to point replicate, because the emission looks really faint in some areas. I want to have like them a little bit more particles. So let's do it. It needs the Pscale for that to work nicely. So we can do like a point replicate. Replicate, yeah, like that. I want this to be 30 points, and the shape can be like a sphere. Maybe we can increase that a little bit. Our particles are a little bit, and also we can add a noise. This frequency, maybe we can increase the amplitude to 3. Yeah, we have like a stronger emission now. Good. Maybe we can even increase the shape to 10. Yeah, like that. But you can see little spheres that are emission, so we need to stretch them. And there's a way to stretch them along the velocity. So let's do a point VOP and call this stretch by V. So velocities are measured in seconds. So if we divide our velocity by by 24, that is the frame rate, and we add that to the position, what is happening is getting the velocity of the particle in the number, and it's dividing by 24. So for a frame, it's going to look where it will be in the next frame, and it's going to add that to the position. So if you set this, they're just moving forward. What we want to do is to negate that. So instead of 24, we can do like minus 24. It's going to go back to where they were. If I compare, if I just plug the position here, you see they're here. They would be a little bit, that's the previous frame where they were. But then if we take the random, I'm going to take the random, I'm going to grab the IG, and I want to multiply that by the random IG. What the random does is give, like, based on each IG, it's going to give a number from 0 to 1, right? Like, I don't know why it's not taking that. Let me just double check. Do we have ID? No. Why we don't have ID? Okay, the point replicate. We need to pass through attributes, copy source attributes. Okay, now we have ID. Okay, but maybe instead of using the ID, because each point, what happens is that it take the point replicate has the same IDs give around them. Like, so if the point has some ID, all the replicated points are going to copy the same ID. So instead of using the ID, we can use the pitching num. Okay, because now every point, doesn't matter what, it's going to have like a 0 to 1 value. Some are black, some are gray, some are white. And if we multiply that by these, the divided velocities, what happens is that some points are going to move forward, backward, some are going to stay in place, and some are going to go like halfway or whatever fraction of that. And then this is the new thing that we're going to add to the velocities. So you see now we have like things stretched, so they are not emitting from one single point, but rather stretched backward. And that's going to give us a much better emission for our simulation. Right, let me save this. And now I'm going to use the pyro source just to give like some attributes to the particles. So let's do like a pyro source. Select. We can initialize source. I don't know, like, or maybe you can just do like this. 2 of those. And the first one, I want density. So it's that the name, and the scale like 0.7. We don't want this to be very dense, and a little bit of temperature, right? We don't need a lot of temperature, but just a little bit, so the particles are just some they can fly up in there as well a little bit. So, but very tiny values, like 0.02 for temperature. And the particle, we can reduce that to 0.3. And that's it. So now we have also some attributes in the particles. We have temperature and we have density. Awesome. And also we have velocities, right? Like, so we have v. So we need to have like all these. And then I want to delete some of the attributes. So let's do an attribute delete again. Attribute delete. We don't care for IG anymore. I don't care for age. I don't care for life. And we keep everything else. IG, age, and life. I didn't select this, so this is what I'm actually deleting. And I'm going to place a null. I'm going to out spray emit. Let's change to another frame. You see how fast it is? So I'm not going to cache this. I'm just going to run straight in here. And in the next lesson, we're going to build our DOP network for the mist simulation, and see you there. Okay, so for this smoke, I actually want them to collide with the sail of the boat, even though we're going to get the sails to simulate and we're going to change it slightly afterwards. I just want it to consider the sail because it can create like some nice vortex around it and can give some interesting shapes for the sails. So we need to build the collision for the sails. So I'm going to get back to the boat, and now this simulation, different than the other ones, we are not simulating the flat. We are already taking the distorted ocean and we're simulating the full thing. So we needed to actually be simulated the original distorted boat for the original position for the boat, right? So the boat should be wherever we're going to render because that's the correct one, and not the one that is back on place to for simulating the flat flip sim. So we need this one that is the same one that we're going to render, and not this one that is the one that we brought back to the flat area, right? And then we need to do the same thing for the sails. So let me do that. I'm going to blast it from the final anim. All right. And I want to delete the sails. So we don't need the mast and all that. Like, it's not going to be noticeable. So I'm just going to keep on the Genoa, delete no selected, and the main. So main sail. And yeah. So we do like a poly extrude. Just a little bit to give like some shape to it. So 0.08, or maybe 1. Yeah. Maybe we need too much resolution for the VDB. I'm going to make it kind of thick. Doesn't matter. And do a VDB from polygons. Again, I think for that, wherever you get like some definition, like 0.2, it's fine. Yeah, this one. If you want to get thinner, so we can do like a VDB reshape STF and erode at the back a little bit. Erode. So it got thinner. It's good. And then I'm going to place a null and say out sail geo. and now it's sales volume. All right. Now I'm going to open that in here so we can copy that and come back to our simulation. And now we're going to do like the real the smoke sim. So it's a little bit different setup. Let me do a regular DOP network. And let's call this spray mist sim. All right. Let me disable that. And we start by bringing some the collisions. So I'm going to bring the boat, and the boat is the one that's in the correct position. So I'm going to make like this, use the form geometry, collisions, intersect volume sample, and the VDB. And then the sales. Okay, so we can use the pyro over sparse and gravity. Also merge. Sparse smoke object sparse. Yeah, this one. Okay, this one to the object. And then you see that what we have here are points, not volume. You can do two things. You can rasterize everything here and then bring into your simulation already like in a volume as the emission, or you can rasterize them inside here. So for that, I'm going to do like a SOP geometry, and we're going to bring that. So let me just copy this guy and the SOP. So here I'm going to make it relative. So if we copy this and do that in another node, it's always going to look up to that. And yeah, I think that's right. Yeah, it's all good. Yeah, just that is good. So there is the gas field, resides field. This guy. Oh, not this one. The fluid dynamic. Gas fluid resize fluid dynamic. This one, what does allow us to do is to understand the size of the smoke and just go like to simulate everything that's inside this. So dynamic increase the size of the bounds based on where we have density. It's going to keep growing, but up to a limit if you define this limit. If you want the smoke to keep simulating forever, it's going to keep growing until there is no density, or the density fades to zero. Then it's going to stop there. But basically, it that allow you to control how much of the bounding box is a dynamic bounding box for like explaining in a better place, in a better way. So I think we can define like the bound of that can be the same one as the other one. So yeah, we can use that, the same one as the wind. This bound that we defined here. Yeah, I think this can be the bound. So what we can do here, yeah, why not? We can just grab that because it's the same area. I wonder if we, because of the camera angle, we won't see. So yeah, it's good. So let's go to the max bound, and density let's keep as is, and the max bound instead of that like to from object. And then I'm just thinking about, because another way that you can do, you can have like a camera, and the camera you can make a volume from this camera, and whatever it's inside this volume you can transform to a geometry, and that could be your bound. So the camera moves and it kills whatever is inside or not. But I think it's fine if we use that. It's not like there's no problem in that. So let's also change the tracking object. We want to track a dop, so it's inside this, and we want the geometry because we didn't simulate. So yeah, that's what we want to track, the geometry. And this one we can merge in here, and in the, is this sourcing? Yeah, we can plug that into sourcing. Also now we need to bring the attributes, right? So like we have the temperature, we have the density, we have the velocity, and we can bring them individually here. So it's the gas particle, because we have that in particle. Is gas particle to field? Yeah, it's this one, right? Because we have the particles and we want to bring them to a volume field. So the first one is density in, right? So the destination field is density. The attribute that we're going to rasterize into is also density. And we want to calculation, we want to add that, and we don't want to do any other thing. It's all good. We can keep that as is. So let me copy this, and this is going to be our temperature in. Same thing apply. If you want to, for example, you can have like a density, and you can bring in here, for example, the attribute can be density, the destination field can be temperature, density, and then you just come to the pre-multiply, source pre-mult, and multiply that by 0.02, and you would be using the density attribute, but multiplying them further down, and then it's going to be stored as temperature. In our case, we do have temperature, so we don't need to do that. Sure. And here we bring that to 1 again. And finally, we can import the velocity. So vel in. The destination field is vel, but the attribute is v. So yeah, we have everything set. We can just double check how is this looking. I'm going to enable that, and let's do like, all right, let me see why it's not working. Yep, there's a few things that I missed. I was just double checking. So here, instead of set the operation default comes to set initial, but what we want is to set always on all of them, so it keep setting, and the for operation here set always as well. So we don't want to just set it to the initial. I'm not sure, like maybe I think it here you can still like set as initial, but I rather say like this. And also I forgot to set like a few parameters here in the shape and the simulation. So let's go ahead and do, so the temperature diffusion we can increase. That means like over time the temperature is going to diffuse and start dropping, because you don't want them to keep rising. It's just like allow them to float a little bit more in there. The cooling rate, if we increase that, is going to cool down over time. That means that the temperature is going to keep dropping. So let's make it like 6, 8, because the particles can just um, do the buoyancy forever. And then in the flames, we don't need we don't have flames, but in the shape, we need to do a couple of things. So first, let's do like some dissipation, increase a little bit, add some disturbance, but not as much. It's just like to break up a little bit the shapes. And the disturbance, you come to the field here, and I just want to increase the block size. So it means the same idea that we have, like we want like bigger chunks of movement to sell the scale of the scene. And the pulse length, we can change a little bit more, like we don't need to do that. Again, a little bit of turbulence as well, just to give some breakup on that. So in the turbulence, we also need to come. I want to increase the size again, the same idea. Everything else we can keep the same. And the wind, I also want to increase to get like the wind. So for the wind, I keep like as 1, and let's do the same wind that we had like there before. We can do like 6 and 10 and 6, but here we don't need to put like wind up because we already have temperature, so it's all good. Let's do just like 1 frame or 2 frames just to see. I'm starting on frame 30 here just to test. Yeah, and now you see we have it emitting properly. Great. Think because this is already very fast, I might even reduce that a little bit, like 9. Yeah, good. And then let's go back to 1, and then let's see where we have like this spray emission starting. I think they only start around 24, so I can start simulating from 25. This one, 25. Yeah, we don't need to waste. And now we have this. You see, we have the values before we were having. So now I'm going to cache, and we will have already this set up for us properly. Next stage, what we do is the splash of the boat itself. We need to emphasize that splash of the boat because just the main sim doesn't give us what you need. And before we dive into the boat splash, I have cached my simulation, the smoke, and there you go. You see the revolution. You can't really tell. You can increase the revolution here in the viewport. If you press D, come to texture and increase this. Like for example, 1024, 1024, 1024. It's going to, you need to refresh, change the frame, and it's going to give you more definition. But this is what I'm getting from the camera view, and it's going to work pretty well. I'm pretty sure you could go even higher res, but what's the point? Like there'll be motion blur and all that, so don't worry too much. Just going to decrease because that can be heavy. Right, and then I want to convert. This is regular volume, Houdini volume. I want to convert to VDB, so VDB convert. And now I want to split, so we can do like a split. Okay, so density. I can do like a no. So this is out spray mist density. And here we're going to also convert is a vector, VDB vector from scalar. So we have like 3 floats, and we're going to have like only one single vector for the velocities. So copy this and say vel. Great, now we can dive in our boat splash sim.